Hello friends, welcome back. Today we are solving Hand of Streets. Alice has some number of cards and she wants to rearrange the cards into groups so that each group is of group size and consists of group size consecutive cards. So the goal here is we have to determine if it's possible to rearrange cards into groups of group size with consecutive card values. Here is an example of some of these groups, and we can notice the cards in each of these groups are consecutive 2, 3, 4, 6, 7, 8. In contrast, this is not a consecutive group because there is a hole in the group. We are given an integer array hand where hand of I is the value of the ith card. For example, in this array hand, value of 0th card is 1, value of first card is 2, so on and so forth. And we have to return true if we can rearrange these cards into groups of size 3 where each group has consecutive card values. Here is another example input array hand. Let's try to see if we can rearrange this input array into groups of size 3 where each group has 3 consecutive card values. The first card we have in the input is 4. How would we make a group of size 3 and one of the cards in that group is 4? Because we have 2, 3, 5, 6 in the input array, there are many possible groups where a card value of 4 can appear. For example, 2, 3, 4 is one group, 3, 4, 5 is another group, 4, 5, 6 is another group. These are all the groups of size 3 and a card value of 4 appears in these groups. So which one of these groups should we pick? How about we pick any one of these groups and try to form more groups using rest of the card values? This approach will work, but it will take exponential time to make all the possible groups. So we have to figure out ways to avoid groups that doesn't make sense to form. So the only way to avoid a lot of unnecessary groups is if we started with the card with the least value. In this example, card with the least value is 1. Because there are no other cards that have value less than 1, there is no ambiguity in what group this 1 will be part of. So card 1 has to be part of a group of size 3 that has cards 2 and 3. So what if we just sorted the input array and repeat this process? Here is the sorted input array. So this 1 has to be part of the group 1, 2, and 3. So we have to remove one card 2 and one card 3 from the list of available cards to use. So we go to the next available card of the least value and it happens to be 1 again. So we form the group 1, 2, and 3. So we get rid of card 2 and 3. The next available card with the least value is 4, and 4 can only form a group with 5 and 6. Let's get rid of 5 and 6. The next card with the least value is 6. It can only form group with 7 and 8. Let's get rid of 7 and 8. There are no more cards left, so we return true here because we were able to rearrange all the cards into groups of 3. So the question is, do we really have to sort all the cards? Well, think about it, right? Any group that 1 is going to be part of is going to look identical. So if there are 10 ones, all those 10 groups where 1 is part of is going to look identical to this group. As long as we know how many ones we have, if we ensure at the very least if we have same or more number of 2s and 3s, we'll be able to use all the cards of value 1 and put them into correct groups. This indicates that we have to maintain a hash table to save the number of cards we have of each value. Now we repeat the same process we did before after sorting all the card values in this hash table. So we start with 1. We know that there are 2 cards of value 1 and 1 can only part of this group 1, 2, and 3. We need to have at least 2 2s and 2 3s. And we see that's the case. which means we can form this group and we set the count to 0 for all of them because we have used each of those cards. We continue to go through this hash table and find the next card with the least value that has the count greater than 0. In this case, 4. 4 can only be part of the group 4, 5, 6, and there's only one card of value 4, so we check if we have at least one card of value 5 and 6, which is the case. So we set the count of 4 to 0, count of 5 to 0, and count of 6 to 1 because we only used one card of value 6. We again tried to find the next card with the least value, which is 6. Now 6 can only be part of the group 6, 7, and 8. There is only one 6, so we check if there is at least one 7 and one 8, which is the case, so we set the count of all these to 0. And we ended up using all the cards. That means we were successful in forming the groups, utilizing all the cards, and we returned true. This is our final algorithm. So the runtime of this algorithm is we have to sort all the cards with a unique value. Let's call the cards with a unique value as m. Sorting takes m log m time. Plus, because we iterate through this hash table to keep finding the card with the next minimum value, and we expand around that card value up to group size minus 1. Notice we don't expand for each and every unique card value. So on an average, we'll spend off n time, n is the number of cards, doing the sliding window type of technique around card of unique value. So the overall runtime of this algorithm is of m log m plus n, where m is the number of unique cards and n is the total number of cards. Let's write the code for this algorithm. First, we have to build a hash table of all the cards with unique value. We can do that using counter. Counter of hand. Let's call this as available because these are all the cards that are available to us. Next, we have to go through these cards of unique value in the sorted order. So for card in sorted available, we are sorting the hash table here because the keys of this hash table are the cards with the unique values. Now, we assume that this card we picked will be the first card in the group. That means we have to look for next consecutive group size minus 1 cards. So for I in range 1 to group size, this will give us a count of group size minus 1. So we have to ensure that any consecutive card we pick, the count of it has to be at least greater than or equal to the count of the first card. Let's call count of the first card as count is equal to available card. So we check if count of the consecutive card we picked, which is card plus I, if it's less than the count of the first card, that means we cannot form this group, so we return false here. If not, we'll be able to use this consecutive card of count. So we decrement the count of this consecutive card by the count of the first card. Once we are done forming this group, we set the count of the first card to 0 because we formed all the groups where this first card will go, and all these groups are identical. When we pick the next card with the smallest value, we just have to check that the count of that card is greater than 0. So if count of the first card is equal to 0, that means we do not have this card available because we have already formed groups with this card. So we skip this card. Once we are done using all the cards that are available, we can just return true because we were successful in using all the cards in the groups. Let's try to submit this code. As you can see, the submission goes through. If you like the work I'm doing, please support by liking the video and subscribing to the channel. And I will see you in the next video. Thank you.